Now, which are the different criteria for congruency of triangles are there? Let us check it out. So, in the 8th standard, you have already learned 4 criteria. They are SAS congruency rule, ASA congruency rule, SSS congruency rule and RHS congruency rule. What are these? How to solve the problems related to this? Let us discuss. Okay. First one, SAS congruency rule. What is the meaning of this? S means side, A means angle, again S means side. That is side angle side congruency rule. So the definition of this is, two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and included angle of the other triangle. Getting two sides and one included angle of one triangle should coincide with the two. See, these are the two triangles we are taking, ABC and PQR. So AB should be equal to PQ, AC should be equal to PR and included angle A should be equal to angle P. Then we can say these two triangles are congruent. Only by checking the 3 criteria we can implement this thing. Clear, children? Now one problem we will take and we will discuss this concept. Now the first problem is like this. AB is a line segment and line L is its perpendicular bisector. So, we are drawing a AB line. For that, one perpendicular we have to draw. Okay. If point P lies on L, this is L, one point we are considering, that point will be P. So, you have to show that P is equidistant from A and B. This is the problem. That means PA is equal to PB. This is the thing you have to show. Okay. So, first, by drawing the figure, we got two triangles here. Just observe, this is one triangle and this is one more triangle. Which is this triangle? This is PCA. And one more triangle is PCB. Consider both the triangles, children. Which are the triangles you are considering? PCA and PCB. This one and this one. Getting? Now, in this, because it is a perpendicular bisector, they are saying this side will be equal to this side. The base will be divided into two equal parts. That's why AC will be equal to BC. So, because C is the midpoint, they only set. Okay. Now, this angle, because it is a perpendicular bisector, it will be 90 degree. So, PCA will be equal to PCB, that is 90 degree. They only given. And you can observe, PC is the common side for both the triangles. It is the common side, isn't it? So, this side is common for both. That's why PC is equal to PC, which is the common side. Now, you can observe here side, angle, side. Which postulate it is? Yes, SAS postulate. Congruency we got. So, we can say that triangle PCA is congruent to PCB. From which rule? From SAS rule. If these two are congruent, so the remaining sides and remaining angles will be equal. But for us, only side is required. So, we can say PA will be equal to PB from the CPCT. So, in this way, you have to prove the problem, children. Okay. Now, we will move to the one more congruency, that is ASA congruency rule. What ASA means? A means angle, S means side, again A means angle. Angle side angle congruency rule. That means here two angles and one side should be considered. Okay. So what it states, let us check it out. Two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of other triangle. So what is the meaning of this? See here. We have taken two triangles PQR and DEF. So two angles, that is Q should be equal to E. R should be equal to F. And on which side these angles are formed? On QR we have formed and EF. That means this side should be equal to this side. Then we can say that PQR is congruent to DEF. This is the meaning of this ASA congruency rule. Got up? So even we can write it as AAS also. So we say what AAS says means two triangles are congruent if any two pair of angles and one pair of corresponding sides are equal. Okay. One pair of corresponding pair of sides are equal, then we can say that it is AAS congruency rule. Clear, children? Now we will go with the one of the problem related to this. So this is the problem you are having. Line segment AB is parallel to another line segment CD. So AB is a one line. For this you draw one more line, one more parallel line CD. Getting? So O is the midpoint of AD. That means we have to join AD here. And O will be the midpoint of this. This side will be equal to this. Okay. Now, what you have to show? AOB. That means even you have to join this side also. Okay. So, this triangle. AOB is congruent to this triangle. Getting? And even O is the midpoint of this side. That is BC side you have to show. These are the two things you have to show. Now, because we have to prove the congruency of these two triangles, you have to consider these two triangles only. Consider AOB and COD only. Okay, DOC only. Now, which will be equal? Just to check it out. See, already these two are parallel. We are getting alternate angles, isn't it? So, ABO, Z shape, where you are getting? Here it is Z shape. So, this angle will be equal to this, isn't it? So, which is that? ABO will be equal to OCD or DOCO. Okay. Alternate angles where AB is parallel to CD. In the same way, this one, AOB will be equal to this. Why? Can you say? Into mark. Vertically opposite angles. So, whenever two lines intersect, you will be getting a vertically opposite angles. And always vertically opposite angles are equal. Even here, one pair of vertically opposite angles you are getting. And already they have given O is a midpoint of AD. Therefore, AO will be equal to OD. They only given, isn't it? That's why you can observe here. We got an angle and side. Isn't it? So, from which congruency rule we can apply here? AAS congruency rule you can apply, and triangle AOB will be congruent to triangle DOC. Got up? If they are congruent, now automatically we can say that the remaining side, that is OC will be equal to OB. CP, CD. If they are equal, this is equal to this means O will be the midpoint of this line. Isn't it? Yes. That's why O is the midpoint of BC. Clear? Now, we will take one problem from the exercise now. So, L and M are two parallel lines. See, these are the two parallel lines intersected by another pair of parallel lines P and Q. Okay. Show that triangle ABC, this one. is congruent to triangle CD. This one. Getting? So you have to prove the congruency. Now consider the set triangles ABC and CDA you consider. In this, what are you getting as a equal? You just check it out. Z shape is there because L and M are parallel. So this angle will be equal to this. Which are the angles? You just check it out. Okay. And already because this distance will be equal, we can take AB is equal to CD first. Because L is parallel to M. Then you go with the ACB. ACB is equal to, this should come here children and this should come here. ACB will be equal to DAC, alternate angles, and AC is the common side for both the triangles, isn't it? So now what you got? Yes, one side, one angle and one side. That's why triangle ABC is congruent to triangle CDA. From what? From SAS rule. Now we got the proof. This is the proof we had to make. We got the proof. Clear? Now the remaining problems we will discuss in the next class. Thank you children.